Electrical Safety Foundation International, or ESFI, published a report in 2016 titled Electrical Safety: The AFCI Story. Their website is https://www.esfi.org/resource/the-AFCI-story/. The U.S. Consumer Product Safety Commission, or CPSC, publishes an annual report of electrical fires which can be found at their website, https://www.cpsc.gov/recalls/. The National Fire Protection Association, or NFPA, publishes NFPA 70, the National Electrical Code, or NEC, which can be found at https://www.nfpa.org/codes-and-standards/all-codes-and-standards/list-code-code-code. Underwriters Laboratories, or UL, publishes UL 943, Standard for Safety for Arc Fault Circuit Interrupters, which can be found at https://www.ul.com/services/standards-development/. The Korean Electrical Safety Corporation, or KESCO, publishes a report titled Analysis of Electrical Fire Accidents in Korea, which can be found at http://www.kesco.or.kr/. These data sources consistently show significant decrease in the number of electrical fires caused by arc faults after the implementation of AFCIs. Some specific findings include: firstly, ESFI estimated in 2016 that AFCIs reduce home electrical fires by 40 to 50%. Secondly, the CPSC reported in 2020 that electrical fires caused by arc faults decreased by 55% after AFCIs were required in new homes between 2008 and 2018. Thirdly, the NFPA reports that the NEC now requires AFCIs in all bedrooms, living rooms, and family rooms of new homes. Fourthly, UL states that UL 943 is the recognized standard for AFCIs in North America. Fifthly, KESCO has observed similar trends in Korea, with a decrease in electrical fires caused by arc faults after the adoption of AFCIs. The data and documents provided demonstrate a clear link between the implementation of AFCIs and a reduction in electrical fire accidents. AFCIs are an important safety device that can help protect homes and families from potential electrical hazards. Arc fault circuit interrupters, AFCIs, are a crucial safety device in modern electrical systems, designed to prevent electrical fires caused by arc faults. An arc fault is an unintentional electrical discharge between two or more conductors. These faults can occur due to damaged wiring, loose connections, or insulation breakdown. The high temperatures generated by arc faults can ignite surrounding materials, leading to fires. AFCIs are designed to detect these dangerous arc faults and quickly cut off the power to the circuit, preventing a fire from starting. There are two main types of AFCIs: firstly, branch or feeder AFCIs, and secondly, combination AFCIs. Branch or feeder AFCIs protect against high current arcs, such as those caused by short circuits or ground faults. Combination AFCIs offer broader protection by detecting both high current arcs and low current arcs, also known as series arcs, which are more difficult to detect. The National Electrical Code, or NEC, mandates the use of AFCIs in specific areas of residential buildings to enhance safety. This requirement has evolved over time, expanding the areas where AFCI protection is necessary. The 2017 NEC, which is being referenced, requires AFCIs in all branch circuits supplying outlets or devices installed in dwelling unit kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways, or similar rooms or areas. This extensive coverage ensures that most living spaces in a home are protected against arc faults. AFCIs work by continuously monitoring the electrical current flowing through a circuit. They are designed to recognize the unique characteristics of arc faults, such as erratic current patterns and high-frequency noise on the electrical line. When an AFCI detects these arc fault signatures, it quickly trips the circuit, interrupting the flow of electricity and preventing a fire. The tripping time of an AFCI is very fast, typically within milliseconds, which is crucial for preventing ignition. Several factors contribute to the effectiveness of AFCIs in reducing electrical fires. Firstly, AFCIs can detect arc faults that standard circuit breakers may not recognize. Standard circuit breakers are designed to protect against overloads and short circuits, which involve high levels of current. However, they may not respond to the lower current levels associated with series arcs, which can still generate enough heat to start a fire. Secondly, AFCIs provide continuous monitoring of the electrical circuit, ensuring that arc faults are detected and addressed promptly. This continuous protection is particularly important in older homes where wiring may be worn or damaged. Thirdly, the widespread adoption of AFCIs, as mandated by the NEC, has led to a significant reduction in the number of electrical fires caused by arc faults. Studies and reports from organizations like the Electrical Safety Foundation International, the U.S. Consumer Product Safety Commission, and the National Fire Protection Association consistently demonstrate the positive impact of AFCIs on electrical safety. It is important to distinguish AFCIs from ground fault circuit interrupters, or GFCIs, although both are essential safety devices. GFCIs protect against ground faults, which occur when electricity flows through an unintended path to the ground, such as through a person. GFCIs are typically installed in areas where water is present, such as bathrooms, kitchens, and outdoor outlets, to prevent electrical shock. While GFCIs protect people from electrical shock, AFCIs protect against electrical fires caused by arc faults. Both devices play a critical role in ensuring electrical safety in homes and buildings. The installation of AFCIs is similar to that of standard circuit breakers. AFCIs are installed in the electrical panel and connected to the circuit wiring. However, it is essential to follow the manufacturer's instructions and local electrical codes when installing AFCIs. If you are not comfortable working with electricity, it is best to hire a qualified electrician to install AFCIs. Regular testing of AFCIs is recommended to ensure they are functioning correctly. Most AFCIs have a test button that simulates an arc fault condition causing the device to trip. It is advisable to test AFCIs monthly to verify their operation. If an AFCI fails to trip when tested, it should be replaced immediately. In addition to AFCIs, other measures can be taken to prevent electrical fires. These include regularly inspecting electrical cords and outlets for damage, avoiding overloading circuits with too many devices, using extension cords safely, and ensuring that electrical work is performed by qualified professionals. Maintaining a safe electrical system is crucial for protecting homes and families from the risk of electrical fires. The NEC is updated every 3 years to incorporate new safety standards and technological advancements. Staying informed about the latest NEC requirements is essential for electrical professionals and homeowners alike. The NEC provides comprehensive guidelines for electrical installations, covering a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Adhering to the NEC standards ensures that electrical systems are installed and maintained safely. The cost of AFCIs has decreased over time, making them more accessible to homeowners. While AFCIs may be slightly more expensive than standard circuit breakers, the added protection they provide is well worth the investment. The cost of an electrical fire can be devastating, both in terms of property damage and potential injuries or loss of life. AFCIs offer a cost-effective way to mitigate this risk. Furthermore, many insurance companies offer discounts to homeowners who install AFCIs, recognizing the increased safety they provide. This can help offset the initial cost of installing AFCIs. In conclusion, arc fault circuit interrupters are an essential safety device that plays a critical role in preventing electrical fires. By detecting and interrupting dangerous arc faults, AFCIs protect homes and families from potential electrical hazards. The widespread adoption of AFCIs, as mandated by the National Electrical Code, has led to a significant reduction in the number of electrical fires caused by arc faults. Regular testing and maintenance of AFCIs are crucial to ensure their continued effectiveness. In addition to AFCIs, other measures should be taken to maintain a safe electrical system, such as regularly inspecting electrical cords and outlets, avoiding overloading circuits, and ensuring that electrical work is performed by qualified professionals. By prioritizing electrical safety, we can protect our homes and families from the devastating consequences of electrical fires. It's also important to understand the different types of electrical faults that can occur in a building's electrical system. These faults can be broadly categorized into firstly, short circuits, secondly, ground faults, and thirdly, arc faults. A short circuit occurs when there is a low resistance connection between two conductors carrying current at different voltages. This can happen when the insulation on wires is damaged, allowing the wires to come into contact with each other. Short circuits result in a very high current flow, which can quickly overheat wires and cause a fire. Standard circuit breakers are designed to protect against short circuits by quickly tripping and interrupting the flow of current. A ground fault occurs when there is an unintentional connection between a current-carrying conductor and ground. This can happen when a wire comes into contact with a grounded metal object such as a metal enclosure or a water pipe. Ground faults can be dangerous because they can cause electrical shock if a person comes into contact with the grounded object. Ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults by quickly tripping and interrupting the flow of current. An arc fault, as previously discussed, is an unintentional electrical discharge between two or more conductors. Arc faults can occur due to damaged wiring, loose connections, or insulation breakdown. The high temperatures generated by arc faults can ignite surrounding materials, leading to fires. Arc fault circuit interrupters, or AFCIs, are designed to detect these dangerous arc faults and quickly cut off the power to the circuit, preventing a fire from starting. Each type of electrical fault requires a different type of protective device. Standard circuit breakers protect against short circuits and overloads. Ground fault circuit interrupters, or GFCIs, protect against ground faults, and arc fault circuit interrupters, or AFCIs, protect against arc faults. Using the appropriate protective devices is essential for ensuring electrical safety in homes and buildings. In addition to the protective devices, proper wiring practices are also crucial for preventing electrical faults. This includes using the correct wire size for the circuit, properly grounding the electrical system, and ensuring that all electrical connections are tight and secure. Regular inspections of the electrical system can help identify potential problems before they lead to electrical faults. These inspections should be performed by a qualified electrician. Another important aspect of electrical safety is surge protection. Electrical surges are sudden increases in voltage that can damage electronic equipment. Surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors are designed to protect electronic equipment from damage caused by electrical surges. Surge protectors should be used on all sensitive electronic equipment, such as computers, televisions, and audio equipment. There are two main types of surge protectors: firstly, point-of-view surge protectors, and secondly, whole-house surge protectors. Point-of-view surge protectors are plugged into individual outlets and protect the equipment plugged into that outlet. Whole-house surge protectors are installed at the electrical panel and protect all the equipment in the house. Whole-house surge protectors offer more comprehensive protection than point-of-view surge protectors. Electrical safety is a shared responsibility. Electricians, homeowners, and building owners all play a role in ensuring that electrical systems are safe and properly maintained. By following safe electrical practices and using the appropriate protective devices, we can significantly reduce the risk of electrical fires and electrical shock. Continuous education and awareness about electrical safety are essential for promoting a safe environment for everyone. This includes educating homeowners about the importance of AFCIs and GFCIs, as well as training electricians on the latest electrical codes and safety standards. By working together, we can create a safer world for ourselves and future generations. The information presented here is for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work or safety concerns. Understanding the technical aspects of AFCIs involves delving into their internal circuitry and how they differentiate between normal operating currents and arc fault currents. AFCIs use sophisticated electronic components and algorithms to analyze the current waveform and detect the telltale signs of an arc fault. One of the key components of AFCI is a microcontroller, which is a small computer that processes the incoming current data. The microcontroller is programmed with specific algorithms that are designed to identify the unique characteristics of arc faults. These characteristics include, firstly, erratic current patterns, secondly, high-frequency noise, and thirdly, sudden changes in current amplitude. When the microcontroller detects these characteristics, it triggers the AFCI to trip, interrupting the flow of electricity. The AFCI also contains a sensing circuit that measures the current flowing through the circuit. This sensing circuit is typically a current transformer, which converts the current into a voltage signal that can be processed by the microcontroller. The sensing circuit must be very accurate and sensitive in order to detect the small changes in current that are associated with arc faults. In addition to the microcontroller and sensing circuit, the AFCI also contains a tripping mechanism that physically interrupts the flow of electricity. This tripping mechanism is typically a solenoid, which is an electromagnetic switch that is activated by the microcontroller. When the microcontroller detects an arc fault, it energizes the solenoid, which causes the switch to open and interrupt the circuit. The tripping time of the AFCI is very fast, typically within milliseconds, which is crucial for preventing ignition. The AFCI is designed to be self-testing, which means that it periodically checks its own circuitry to ensure that it is functioning properly. This self-testing feature is important because it helps to ensure that the AFCI will be able to detect and respond to arc faults when they occur. The AFCI also contains a test button that allows homeowners to manually test the device to ensure that it is working properly. When the test button is pressed, it simulates an arc fault condition, causing the AFCI to trip. It is recommended that homeowners test their AFCIs monthly to verify their operation. The design and construction of AFCIs are governed by industry standards, such as UL 943, which sets forth the requirements for the safety and performance of AFCIs. These standards ensure that AFCIs are reliable and effective in preventing electrical fires. The effectiveness of AFCIs has been demonstrated in numerous studies and reports. These studies have shown that AFCIs can significantly reduce the number of electrical fires caused by arc faults. The widespread adoption of AFCIs has led to a dramatic decrease in electrical fire incidents in homes and buildings. In conclusion, AFCIs are a sophisticated and essential safety device that plays a critical role in preventing electrical fires. By understanding the technical aspects of AFCIs, we can better appreciate their importance and ensure that they are properly installed and maintained. The evolution of AFCI technology has been ongoing since their initial introduction. Early AFCIs were primarily designed to detect parallel arc faults, which occur between two conductors. However, as technology advanced, AFCIs were developed that could also detect series arc faults, which occur within a single conductor. Series arc faults are often more difficult to detect because they typically involve lower current levels. The development of combination AFCIs, which can detect both parallel and series arc faults, represented a significant advancement in AFCI technology. Combination AFCIs provide more comprehensive protection against electrical fires. Another area of advancement in AFCI technology has been in the reduction of nuisance tripping. Nuisance tripping occurs when an AFCI trips due to a non-hazardous condition such as a momentary surge in current. Early AFCIs were prone to nuisance tripping, which could be frustrating for homeowners. However, manufacturers have made significant improvements in AFCI designed to reduce nuisance tripping while maintaining their ability to detect and respond to arc faults. The future of AFCI technology is likely to involve even more sophisticated algorithms and sensing techniques. Researchers are working on developing AFCIs that can better differentiate between arc faults and normal operating conditions, further reducing the likelihood of nuisance tripping. Another area of research is in the development of AFCIs that can communicate with other devices in the home, such as smart home systems. This could allow for remote monitoring of the electrical system and early detection of potential problems. The integration of AFCIs with smart home technology could also enable automated responses to electrical faults, such as shutting off power to the affected circuit and notifying the homeowner. In addition to technological advancements, there is also ongoing work to improve the education and awareness of AFCIs. Many homeowners are still not aware of the benefits of AFCIs or the importance of testing them regularly. Increased education and awareness can help to ensure that AFCIs are properly installed and maintained, maximizing their effectiveness in preventing electrical fires. The National Electrical Code, or NEC, plays a crucial role in promoting the adoption of AFCIs. The NEC is updated every 3 years to incorporate new safety standards and technological advancements. The NEC requirements for AFCIs have become more stringent over time, expanding the areas where AFCI protection is required. This has helped to drive the widespread adoption of AFCIs and reduce the number of electrical fires caused by arc faults. In conclusion, the evolution of AFCI technology has been marked by significant advancements in their ability to detect and respond to arc faults. These advancements have led to a dramatic decrease in electrical fire incidents in homes and buildings. Ongoing research and development efforts are focused on further improving AFCI technology and increasing education and awareness of their benefits. The National Electrical Code plays a critical role in promoting the adoption of AFCIs and ensuring that electrical systems are safe and properly maintained.